Alright, here we are. This will just be I recommend you to watch this in case you're stuck on one of these problems. I hope you would attempt it before you watch my solution, but I mean, as long as you're learning, that's what matters. So, um, okay, for this case, we're just going to start off with doing all the word problems. So 210. So these first couple pages are just going to be typing it as you see it, Divided by 0.741, you get your answer. Let me actually edit so I can draw. I'm going to be drawing with a cursor, which is never good, but it'll be good enough. So 283. That's your answer. Second problem, find the cube root of the sum. So you follow it in terms of how it puts it. So you're first finding the cube root. So the cube root, and basically in parentheses, sum of. So you're taking this, if that helps. You probably already know that. Alright, the cube root of 4.45, and since it's the sum of a negative and a positive, you could put it in a form like this. Minus 7.84, and you'll get your answer to be negative 1.5.50. Don't forget the 0. Okay. Find x at the average and yada yada yada. So you could use the numeric solver, or you could just say that you can multiply this by 3. Right, and the other 3 added together should equal that. 5.6 times 3, that's equal to all of these added together. So you could just subtract 9.8 and subtract 8.88, and you'll get your answer to be negative 1.88. Okay, very friendly. Perimeter problem. So regularly, the perimeter of a circle is 2 pi r, right? But in this case, it's a semicircle, right? We're trying to get this right here. This right here, it would be half of 2 pi r, which is just pi times r. That's not the only perimeter of this shape, though. You also have 2 2r right here. So it's 2r plus pi r, which you could rewrite as, in parentheses, 2 plus pi, and then you can multiply it by r, which is 75.5. And you get your answer to be 388. Okay, that was a terrible 8. 388, and then another area problem is just a square, so you just take the square of it. 4.34 squared. I thought I pressed the 3 key, but I guess not. Things sometimes a little bit iffy, so I might make a couple misclicks here and there. There you go, 18.8. Okay, well that's it for that page. Very friendly. You should know how to do most of that. Oh, that's the last problem, I'm pretty sure. Or from a different test even. Okay. So, let me get the little pen out again. This time I want to be in red. I feel like red's a good color for this. Here we go. Alright, let's go up to 5. So, Mars Company produces 400 million M&M candies daily. How many produce in 1 second? Well, this is just a simple conversion. So it's 400 times 10 to the millionth, sorry, not to the millionth, just 10 times, 400 times 10 to the 6th. That's the same as 400 million, just you don't have to type as many zeros. And then that's daily. So you're going to put it in hours by dividing it by 24. That's how many produced per hour. And then dividing it by 3600, because there's 30,600 seconds in an hour. And your answer is 4,630. That's a lot of candies in 1 second. Yikes. Alright. So now we have a jog runs a mile in 8 minutes 26 seconds. What is the average velocity? Well, we're going to add up these two. So that's how long it takes her to run a mile, right? So since there's 60 hours, sorry, not 60 hours, since there's 60 minutes in an hour, you will be able to run this many times. You'll be able to run that many miles at that pace, which is 7.11. 7.11 miles per hour. So she could run 7 miles per hour. She can run 7 miles in an hour at that pace. So, here we go. So 2.5 miles per hour, and a river flows at that much. So positive difference. So it's asking us, right, going with the flow or going without the flow. So he's either gonna be rowing or he's not gonna be rowing. But it's downstream both times though. So that 4 miles an hour is constant, but it's either gonna be by itself or it's gonna be 6.5 because he's rowing alongside. Actually, I won't even need the equation solver for this one. So 4 miles, so it's 1.8 miles, right? Divided by 4 miles an hour, that's how much of a mile it would be, right? Same with this. You would do 1.8 again, divided by 6.5, because you're adding his rowing speed plus the river speed, and that's how much of a mile it would take. Sorry, that's how much of an hour it would take. You subtract the two, and that's how much of an hour is in difference, but it's asking us in minutes. So you'd multiply it by 60, and you get your answer to be 10.4. Let me make sure that I'm following along. Okay, just want to make sure I'm not giving any wrong answers right now, you know? That would not be good. Okay, so now we have an area problem, and typically, whenever there's an area problem, let me try redrawing that. If you have to do more than 2 steps with these 19s and 20s, I actually normally use the program. I could solve it by hand, but I feel like if it's 2 steps, like finding this side, that side, and then multiplying them and dividing it by 2, I feel like it's faster just using the program, which is angle, side, 90, 50.6, and then 1.7. Oh, like I said, sometimes I'm going to misclick. And then finally 1.74, and you'll just keep on pressing enter until it gets to area. Oh, I misclicked again. There we go, 0.742. So that's pretty easy. You could, like I said, you could do it by hand, but I feel like using a program is faster when it's 2 steps. Now for this one, it's only 1 step, which is why I'm going to do it by hand. We're going to use SOHCAHTOA. That's the hypotenuse. That's the opposite. So it's going to be sine, because it's so, right, over h. So it's the sine of theta is equal to over h. Normally you don't write this many steps, but I want to show you how I'm getting my answer. So this, you're going to have to isolate theta, right, because you're solving for it, unless you want to use the numeric solver. But you want to isolate theta, which is why you're going to take the inverse sine of both sides. So you're going to be left with sine is equal to, sorry, not sine, theta is equal to the inverse of sine of over h. That's why you don't even need the numeric solver. You could just do second sine. You want to make sure you're in degrees, by the way, which you could tell by the top right. Sine of over h, 0.41 over 0.736. See, I thought I clicked the 6 there. This thing is very finicky. All right, 33.9. That's the correct answer. Moving on. There we go. All right, let me flip my page. So this one's going to be really handy using the side tools. So I probably, in this scenario, I'd probably go from, oh, let me pull my little pen again. So I don't have to do this every time, but it's not too much of a hassle, luckily. So we have feet and we have gallons. So before I say that first, I should read the problem. So it's an error problem, of course. So it's marked as this. This is like the estimate, this is the error, and this is the actual, right? That's too thick. It's covering up some of the numbers, so I'm going to get rid of that. But you know what it says. So yeah, it's a percent error problem. So this is the actual, like I said, I'm terrible at drawing, and this is what it's predicted, you know. So if you know the formula, it'll be really easy. First, you have to convert it. Oh, even before that, let me figure out what the volume is in feet squared. So it's 1 foot by 1 foot and 4 inches by 4 feet. So since it's only a 1 foot in like width or height or however you want to put it, you don't even have to worry about that. So you could do 1 times 1 and so on and so forth, but I'm not going to worry about that. So in parentheses, 1 plus 4 inches is a third of a foot. 1 plus 1, 3. 1 over 3, sorry. And multiply that by 4. So it's 5 and 1/3. 5.33 repeating. So side tools, the unit converter again, volume. So in the numeric solver, it doesn't allow you to do pluses or anything. So whenever you're having to, or a division, So you normally just you just keep on clicking and maybe a few bit. So that should be good enough. That should be good enough. But yes, we're going from feet cubed, which is in the very corner, to gallons. There we are. And you're going to export that by clicking the little zoom button right there. And whenever you exit the program or the app, it'll be right there. And that is what the actual is. And with the formula, you do the predicted, which is 45, over the actual. Or that's not predicted, that's estimated, but same difference. And then you minus subtract 1 and multiply by 100, and you get your answer to be 12.8. 12.8. Yes, this run through is gonna take a little bit longer. You might even see the video length, but I'm just trying to be I'm trying to be in depth whenever I'm solving this. So I should probably keep that there. I didn't mean to delete that. Okay, so a chicken will lay on average 2 eggs every 3 days. That's 2 over 3 per day. Okay, let me draw it over here. 2 over 3. And it's asking weekly how many will be needed to produce 20 eggs weekly. So that right there is how many eggs a chicken by themselves will lay. That's how many eggs a chicken will lay by themselves a week. But we need 20 dozen. So 20 multiplied by 12 because we're having to get how many eggs, and we're going to divide it by the number of eggs made by each chicken, and that's how many chickens we're going to need. But it's an integer problem. You can't have 0.428 of a chicken. So since we need at least 20 dozen eggs, we're going to go and say it's 52. Because if we had 51, it wouldn't be enough. We would be getting very close to 20 dozen eggs, but we wouldn't reach the threshold. So that's your answer. Uh, Now this is an inflation problem. There's other ways you could do it, but I'll take the time to show you my program just because I'm proud of it. It has a whole bunch of stuff in here, but we're worried about the simple interest. So starting amount 32,500. There we are. Inflation rate 2.6. And this is also showing you how to use it. That's why I do this. 12 years, it says right there. 12 years. And the final amount, we don't know. Because although this is the actual the final amount, we're asked for like basically the predicted. What should it be if it was still the same value, right? So it tells us the final amount is that much. Oh, I forgot I could drag that screen. I don't really want to though. So it's stored under F. It doesn't show it, but it's stored under F for final. Most of the time these are pretty straightforward. Sorry about that. My mic cut out. So now that we have this is the predicted, right? This is how much it should be worth. Although it's only worth this much. So we're asked for how much value has it lost. So we're gonna do the actual minus, or sorry, it's either gained or lost, but in this case, the predicted, if it kept up with inflation, it should be higher. So of course it's the lost value. So you're going to do the lower value, the actual, minus the predicted, and you'll get your answer to be negative 1,223.36. That's a lot. And since it's a money problem, you have to go all the way to a penny. It's a lot. Okay, so now we have two geometry problems. It's very friendly. I'll just run them through really quickly. So geomfig, of course. Sphere, which is 7. We're given the radius, 5.26. And total surface area. Press enter. There you are, 348. It's very handy. And then it'll run this again since there's two of them. Frustrum right there, number 4. We're given both the radii and we're given the height. So we're actually given the diameters, which is why we're going to have to divide each of them by 2. But that doesn't take too long. And then 0.473. And again, it will give you your answer on the second screen. So we're asked for the volume, 0.0741. Alright, that's pretty friendly. So those were the first 3 pages. We're going to keep on going. So we're almost halfway. And I don't know, we're at 15 minutes? Okay. I think we should be able to get this done in 30 minutes. We'll see. Okay. So, I might actually need a little bit more room for that top problem. Wish I had a little bit more white space. I guess I could use this right here. Okay. No, I don't want to save it. I just want to, no, mark up. There we go. Okay. So, this problem is a little bit difficult if you don't understand what it's asking. So, of course, you know what record players are, you know, it's the little, has like the outside with the actual record part where it records data, and the little center part where it's a hole because you set it in there, you know, it clips in like a CD. So this it's asking us about the shaded region. This shaded region is the one that has all the grooves with the data, right? This inner part doesn't. So shoot, I did not mean to do that. Let me just move that back up. Very finicky. Very carefully. Okay, there we go. That's good enough. Okay, so as I was saying, that's how a record player looks. So it gives us the two radii of each. And it tells us the total groove length. So that, the total groove length is all the, let me show you. So like this right here, this is the circumference, of course. That's the little hole in the middle. That could be, I'm very bad at drawing with a mouse. That could be like the circumference, right? There are little grooves all the way in here, right? And they're assumed to be equal distance from each other. There's a groove there, there's a groove there, so on and so forth, right? Very, very close, packed in, right? I can't even really draw it. So, let me try that again. Okay, that's the best I'm going to do. All right, I'm going to keep it there. So, it gives us the both radii. So this radii right here is 2 inches. I'll just write that to the side, and then that right there is 6. So then it gives us how long all, like the combined circumferences from the 2-inch to the 6-inch, all of them are, right? So the good thing about this problem, though, is that we can assume that all of the circumferences have a radius of 4, right? So you're looking here, right? So this is 2, this is 4 right here, because it's the total radii of this whole shape is 6, but you have to subtract the middle. So this is 4, right? So 4, and you're going to have to get to the halfway point, right? And why I'm doing that is because all of these, assuming they're equal distance from each other, right? This, let's say this one, of course, over here, this circumference is going to be, this point on the circumference is larger than this circumference right here. But they meet in the middle, right? All these points meet in the middle. So we could assume that this middle point is, this middle circumference is the circumference of each point because they all average to be that. So knowing that, that's what makes the problem really friendly. So as I said before, this length right here is 4. So halfway here of this from here to there is 2. That's 2 on top of the 2 from here. Right? If you can see my cursor, the 2 here, and add the other 2 from here to there, you get 4. So it's 4 pi times 2. So that's the circumference, that's the average circumference of all of the grooves, right? But that's in inches. So you're going to have to divide it by 12 to put it in feet. There you are. So, that's definitely a big. Oh, that's just an old style. That's not a CD. I was gonna say I was comparing it to a CD, but that'd be a pretty big CD. All right, we're good. I'm pretty sure. So, um, there's 2 feet on average per circumference. We're having to figure out how many grooves there are, right? And then we'll find the distance. So, the total length is 1,500 divided by the number of grooves. Oh, sorry, the average groove circumference, and you get that many grooves, right? We won't have to round that. So you have 716.1 or 0.2 number of grooves. And all those grooves are from 2 to 4, right? So, oh, sorry, 2 to 6, 2 to 6. So it's a distance of 4. So since there's 4 inches between all of them, you're going to have to divide 4 inches by that many. Oh, sorry, I didn't do I thought I did the 4. 4 divided by all of that. There we go. So that right there, since there's 716, in between the 2 marker and the 6 marker, the distance is 4, so they all have to be equal distance from each other. So that's why you divide it, and you get your answer to be, well, that many inches, but it's asking in millinches. So if you don't know, there are 1,000, and like unit conversion, milli, it's like a millimeter to a meter, right? There's 1,000 of them, 1,000 millimeters in a meter. So we're gonna have to multiply by 1,000 over here, and you get your answer. I hope that explanation helps. If it doesn't, then I'm sure you could find another explanation somewhere else. I'm not the best explainer, but I know that's correct. So, moving on, that was definitely a tough problem. It took me a while to solve that on my own. I had to get a lot of help from the ones above me, like Paige, whenever I had him and had her in my class. Okay, moving on though. 37, again, this is going to be a very useful problem for the apps, right? But let's read the problem first. So we're given the weight of the Statue of Liberty, and this, by the way, this is a significant digits problem. We're given the weight in the Statue of Liberty, and we're given its density and its area, right? All of these numbers are in 2 sig figs. You'll have to keep that in mind. That right there, that's only 2. Even though it has 4 zeros, that's only 2. Same with this. It's 2 and 2, of course. So we're going to start this problem, and it's also, my bad, I forgot the actual question. So we're making it into a rectangle, right? With this on the area. So we're basically making it into a rectangle with an area of this, and we're just trying to figure out how tall it would be, right? So pretty friendly. We just have to use a lot of unit conversions. So side tools. First, let's go from pounds to grams. I don't know the conversion off the top of my head, but during a test, it'll only take me like 10 seconds. So on this, of course, it's a little bit harder since I'm having to use a mouse, but it's still pretty easy. 0, 0, 0, 0. Okay. Pounds to grams. And we're going to export that. And then once we have this out here, that's how many grams there are. And since there's 8.2 grams per centimeter cubed, we're trying to find the volume, so we're going to divide it by 8.2, and that's how many centimeter cubes there are in the Statue of Liberty, and then if it was squished into a rectangle. So you're going to write that to the side. 4, 8, 9. Actually, you know what you could do instead? You don't have to worry about that. I realize there's an easier way to do that. Because I was first going to have us go back and put this whole number back in the conversion, but a little bit easier than that though is going from centimeters to feet, right? Because we're going to have to go from centimeters cubed to feet cubed. We're going to use side tools and unit converter again, volume. So we're just going to put 1 centimeter cubed to feet, because this is in essence is what we were going to do anyways, but without having to type that whole long number you saw before. So we're going to export this. This is the ratio. So that's how much of a feet cubed each centimeter cubed is. So that's the conversion from centimeter cubed to feet cubed, and we're going to multiply it. So that's the volume in feet cubed, right? And we know the area is 43 feet squared. So divided by the area, you get how many feet, you get how tall it is, right? The thickness, I guess, is what they call it. Now we're asked it in inches, and we're going to multiply it by 12. And if you're paying attention, right, significant digits, for those that have already taken chemistry and know about it, anytime you divide by a number with 2 sig figs, or if you divide or multiply, you take the number with the least sig figs. Since there's only 2 right here, you only are going to have 2 significant digits at the end. So I hope that helps. So that's why you get, technically we have, several here, but you would only have 2 at the end. Because whenever you divide it by this, you end up with 2, and that's what your answer is going to be in. So it's not 240, 45, I mean, it's 250. Let me redo that. 250. 2 sig figs. Okay. So now we're given a rate problem in distance and time. Okay. So we have a lap. That, of course, that's a regular lap. That is a fourth of a mile. 440 yards, that you should, okay, I keep on drawing over it. I'm going to change the thickness just a little bit lower. 440 yards, that should immediately kind of strike a, I don't know, connection in your head that that's a fourth of a mile, right? It's just a regular lap, as I was saying before. So Richard runs a map in that time. That'll be important later. But Rhonda runs faster. So she laps Richard every 5 minutes. And since we're going to miles per hour, we're going to have to figure out how many times she laps him per hour. So if she laps her every 5 minutes, we'll do 60 divided by 5. And that's how many times she will lap him in a mile. 12. That'll be important. That's how many laps. But as we said before, that's a fourth of a mile. So if you divide it by 4, you get 3. So that's 3 miles per hour faster. So we got the ratio. We got not the ratio, but we got the difference between them, which is 3 miles an hour faster. I'm just going to do plus. So now that we have that, we can look back at this original rate, find the miles per hour, and then just add 3 to it, and we'll get our answer. 8 plus the 45 divided by 60. You could have also, 8.75 if you're good with going from seconds to hours, or seconds to minutes, my bad. So then we could divide that by 60 to figure out how many miles he will run in an hour, and we'll just add 3 to it. 9.86. Wow, that's Rhonda, she runs fast. That is a very fast time. I don't even know if I can run that fast. 9.86 miles per hour. Okay, so now we have that. 39 and 40, both, of course, triangle program. Okay, what are we looking at on time? 27 minutes. I will not be finishing by 30. I hope to end by 45 now. I want to go really far in depth. You know, that's important to me. But I also don't want to take the whole day. I have work later today, so I don't have that time on my hands. Okay, so we're looking for big R. 11.2, and that's just your answer. And then instead of quitting, you can just run through, and the menu will pop back up. Here, we're given that scaling, right? And we know that if we could find this side length, right, by using the triangle program, which I'll do right away, angle side. So that, what is that, 4? Yep. And also those are in radians, and you convert radians to degrees by multiplying by 180 and dividing by pi. So you just do that to both of them. And then once you do that, it'll give you your side length. You got to remember it's angle. This is right here is angle 2. So the corresponding side that we're looking for is side 2, which is 842 yada yada yada. So 842.66. 842.66. We'll quit the program. And now, like normally I run through, but since we just needed to start, we'll open it back up, and that's going to be faster. So now we know we could solve for it because this angle right here is simply 180, since it's a straight line, minus this angle. So knowing that, we could use side angle to figure out our solution, to figure out the missing side. So it's 843. That's almost an isosceles triangle now that I think about it. 842.66. That's very close to being isosceles. I didn't even notice that my first time solving this. All right. And, you know, there's a couple ways. If you didn't know, there are pi radians in one length. Like there's, I'm trying to explain it. So on a straight line, the angle, like right here, 180 degrees, that's pi in radians. That's pi in radians. So you could solve for it by doing pi, the total, like otherwise it's 180, minus 2.17. And then you could also multiply by 180, because that's still in radians. Let's just figure out how many radians this is, and then multiplying by 180 and dividing it by pi. I'm messing up a lot. And then it'll spit out your answers, 951, which is correct. All right, there we are. Yeah, definitely want to steer clear of that thick. What is this? What am I on? 3? I'll use 3 again next time on the next page. Okay, let's go on. Here we are, page 41. It looks like it's a little bit crooked. I'm sorry about that. I'm sure it won't really affect us too much. So for number 46, it's not actually too bad, but I'm sure that even myself during a test, I'm sure I wouldn't have even gotten it. So for this, let me try to explain it by providing an example. So we're told that the pellet dimensions are all reduced by 50%. Now that doesn't reduce volume, nor does it reduce weight, but what it does do though, it reduces. I guess, well, technically speaking, if you only have one pellet, right, and you reduce all the dimensions by 50%, then yes, it would affect volume and weight and all the such. But we're we're keeping all the pellets that we make, right? So we're breaking, in essence, we're breaking a huge pellet. You could treat it like a cube in a sense. We're breaking a cube into, no, we're making it all dimensions by 50%. So we'll have a cube at the bottom. We'll end up with actually 8 cubes, right? Since this cube right here will have all half dimensions, it'll be that corner right there, and then span halfway. Another cube right there, span halfway. Another cube span back halfway, and then the last cube span halfway. And then you'll have the same pattern on the other side. So you'll end up with 8 of these tiny cubes with all half the dimensions, right? But when combined, they all have the same volume and weight, right? But the only difference is their surface area, which is increased. Uh, and if you don't know off the top of your head how much it's increased by, which I didn't, we could just use an example. Let's say that this whole cube had and also I should put times 8. So you remember that there's 8 of those little cubes. So if you don't know off the top of your head, like I said, if you don't know off the top of your head, you can just use an example. Let's say this whole side length is 2, right? So 2 squared. First of all, let's do 2 cubed. So that's the volume, right? Which, like I said before, if you do 1 cubed and you multiply that by 8, because there's 8 little cubes, you'll have the same volume, right? And same with weight, since weight and volume, in this sense, they have the same ratio. So it's consistent. Now let's look at surface area though. So 2 squared times 6, since there's 6 faces, will give you the surface area of this cube right here. Now let's do it to this little tiny cube. That's going to be 1 squared, which is the same as just 1, timesing it by 6, and then timesing it by 8. So if you look, it's double the surface area. So knowing that, you could use the numeric solver. I did not, I thought I used alpha. Okay, let me try that again. Sometimes I misclick and I don't hit things when I was trying to. It's a lot easier with a physical calculator, but I want to show y'all what I'm doing with this one, with this digital one. It's very handy. Alright, so we're told that the 5 pounds of pellets have a total surface area of, actually we don't even need the numeric solver. I actually didn't do it the first time I solved for this either. So how I did it, right? We know that, so we're given 5 pounds and we're going to 3 pounds, right? So that's a decrease in 5/3. So it's 60%, right? If all the pellets had the same side lengths and such, then the surface area would be, the new surface area would be that. It'd be 11.16. But the surface area doubled, right? Since it all were reduced by 50%, by half. So knowing that, once you figure out the ratio and times it by the initial surface area, you're going to double it. And you get your answer. That's how I did it the first time around, but you can do it whatever way you like. As long as you do it correctly. That's the only thing that matters, realistically speaking. Now I don't know on this calculator if I've set it up properly for number 47, but we're asked for the correlation coefficient, so I'll make sure I do. On your calculator, you should know if you have it set up or not, but if you don't, all you have to do for this problem is turn on diagnostic by going to second catalog and just going to D, as I already showed you, and it'll be down there somewhere. Turning it on, running it, and then going to stat, edit. This was from a previous problem I solved for. We're told that she's running around a quarter-mile lap, and those are all the data. Those are all the minutes. And we asked for the correlation coefficient, so we're just going to type it in as we see it. And they're increasing by 0.725 every time. And 1.25. Not 2.25, 1.25. My bad. Alright. And then 1.94, 1.83, and it's not compounding. It's not this doesn't add to that and such. Sometimes they do. Sometimes they throw that problem at you. You just gotta understand when they do and when they don't. You gotta have a sense of, like, I guess, you gotta have a feel for it. That's the best way I could put it. Then where it's gonna be linear, right? Because that's probably the best. Okay, I guess, I mean, yeah, you don't even need to you don't need to save it, but normally with these problems you save it under alpha trace y1 and bam. But yes, you're looking for the R value. That's the same as the correlation coefficient, 0.261. 0.261. Okay, we're doing pretty well right now, if I could say so myself. We're asked, now this is just another simple numeric solver problem. So 13x to the 6th power plus 21x squared is equal to 45. So we just run that. I don't really like having the guess as 0 just because sometimes, especially if x is in the denominator by itself, it will throw you an error. So normally these problems, I just set it to a low number, 1.08. Not too bad, as you could tell. Alright, oh, let me make sure I'm following along in my paper in front of me, just to make sure I'm getting this all right. Okay, so this volume, this for number 49, we could actually use the geomfig program, but we have to do a step first. So we know the total volume of this figure, excluding the hole, because this hole, of course, is taking up space. Yeah, so it's not the entire cylinder volume, but the cylinder volume excluding the hole. Like, how can I put it? So all this area, all this volume, including a little bit over here, all that volume is 7.83. So since we know that it's a cube and it's the same height as the cylinder, we could actually figure out the volume of the cube and then figure out the whole volume, right? And then we could just use the geomfig program. So we could add 0.487 cubed. And that'll just give us the volume of the whole cylinder. And then we know the height, so we just use the geomfig program. So you see, even for the harder problems, sometimes if you look, you can sometimes even use the geomfig program on these. So cylinder 3, we're given the height, and we're given the volume. 0.487 is the height, and then 0.487 again, but we're going to, oh, I did not mean to do 0.44. 0.487 cubed, that's the volume of the cube, plus the volume of the rest of the shape, 0.783. And it'll give us the diameter of 1.53, which is correct. Oh, that was a bad 3. Okay, now looking at this problem, we're given the total volume of this shape, and this is a square right here, but it's a rectangular solid because this is not the same. This is not the same length as these two sides. So we're going to call this side x because that's what we're solving for. Now it also gives us the total height of this figure. Let me fix that x. Gives us the total height of this figure. So this right here, this distance, you could say that the height of the cone is 0.803. 803 minus x, because then we're removing this gap right here, so it would just line up right there. So yes, we could put it in terms of x. So knowing that, all we have to do is go back to the numeric solver and we'll get our answer. This is where it's important to know your formulas in case it doesn't work, like in this scenario. For 49, you could still use geomfig sometimes, but for 50, you have to know it off the top of your head. So 0.342, and since it's multiplying by each other, and then you're going to multiply by x, you can just do squared times x. And you're going to add the cone volume, which is going to be the radius, which is in parentheses 0.342, divided by 2, because that right there is the cone's diameter. And then you're going to square it, times it by pi, and then multiply it by the height, which is 0.803 minus x, all divided by 3. And then that's going to be set equal to 0.05. And you'll solve for your answer, which is 2.99. Wait, that doesn't look right though. Did I type something in wrong, I guess? Squared times pi. I don't see anything off the top of my head, but I don't think that that's correct though. Let me check. 50. We're at 29. Yeah, it's 0.294, which I got before. Well, this is my first stumbling block, I guess. Oh, I forgot the x. Ah, I see. Little mistakes like that. I might have said x, but I just forgot to type it in. Normally I don't announce what I'm solving for, you know. So I got it right the first time, but little hiccup right there, but that's okay. 2.294. Okay. And like I said, normally I probably wouldn't have gotten that wrong. And I actually didn't the first time I solved for this because I solved for this test before I made this video. Um, but since I was announcing everything I was doing, I just completely forgot to type it in, you know. All right, moving on. 2 more pages, almost there. That direction. Okay. You know what? Before I continue, I'm gonna grab some water because I'm a little bit thirsty. What are we at on time? 40 minutes? I'm sure we'll be done within an hour. All right, I'm back. Here we go. Okay, so let me get my pen back here. Oh, I first have to crop it. Here we go. All right, so number 56 is we're going to require the numeric solver again. So it's just going to be, oh, sorry, that's going to be math 8, not math 9. So it's a slope problem. We're asked when the slope of this line equals 2 in between that interval. So it's going to be also, I think it's radians. I'm pretty sure it's in radians, so we'll have to change that. 7 divided by, these problems are almost always in radians, even if they don't say it all the time. So just always assume it's in radians unless you're told elsewise. And the slope equals 2. And like I said, change it to radians, and there we are. If I can go back up. Sometimes it presses keys at the same time for some reason. Alright, there we are. 0.870, and that is the correct answer. It's now 57. I'm not going to lie, that was the one problem I haven't solved, and I don't think I will because, I mean, I'm sure for most of y'all, even myself, instead of solving 57, taking the whole 30 minutes to do it, you should probably do some other problems, you know, some easier ones, which I'll show you in a bit. Okay, so skipping that, now we're asked a matrix problem. These matrix problems, so first of all, I do have to say on this page, 56, 58, and 59 aren't typically that hard. I highly recommend taking the time to do each of one of them. And most of the time you can get it right. Of course, occasionally you might mess up, but it'll be fine. Okay, so we're given the formula for each of these. It's 5 times s, which is this. So it's 6, 7. I really don't like how I don't have a. I can't use 2 fingers when I'm typing in on the calculator. It's so much faster when you do. All right, plus 3, alpha zoom. 2 again, the matrix. 8, 5, 5, and -2. And we're asked for row 2, column 2. So you got to remember that's what it means. The first number is connected to the row, and the second number is assigned to the column. So if you forget that, you can just remember what it appears, what order it appears here, row and then column. And well, in this scenario, it doesn't matter though because you know that it's 2, 2, so it has to be the one in the corner. So it's 34.0. Forgot to put the answer up there before for x. I could just do that now though. It should be still saved under x. 0.870. Okay. Looking here, we've done many of these before, so we're just going to have to do two different sections. One, the first area is going to be used using y equals x, this parent function, and the second one's going to be used using the sine graph. So there's a couple things we have to do first. By the way, for radians, a lot of the time, not all the time, but a lot of the time, it crosses the x-axis at pi, which this graph does. But before we do that, let's just make sure that we'll confirm that it does. Y times the sine of x and just y equals x. Okay, we'll have to remember what order those are in. So I'm sure your calculators are a lot faster than this one. For some reason, even though this is on my computer, it has a pretty slow loading time. But okay, let's go to trace, or no, sorry, calc. And you're going to calculate the intercept right here. Because we can tell that this is the origin. So we're just finding what this is right here. So you get about to where it is, and it's 2.595. So it's saved under X. So I'd recommend just quitting really quickly, pressing X, and having it there. And why I say that is because whenever you're going to calculate the 0, which like I said is already pi, it will replace what value X is. X will no longer be the intercept point. It will be where 0 is. Right here. You see X gets replaced with that. So X now has a different value. So that's very important. Because if you were to try using X again as the first intercept and pi as here, it wouldn't work. Okay, but going on. I was just having a little bit of a rant there. Okay, so 0 to that number, the intercept point, we're going to be using the y equals x. If I'm not mistaken, that's y2. I put it for y2 and then d of x, of course. There you are. That's the first area. And then using math 9 again, we're going to go from that point. Can I not? Oh, wait. I might not be able to even. I don't think I can. Shoot. That's annoying. You see, it'll go to the top part, not the bottom. I want it at the bottom. Now, I guess I won't be able to do that, so I'll just type in I see it above. 7, 4. That should be more than enough. And then we're going to pi. And we're using y1 this time. And d of x. Okay, and then just add these two up. And you get your answer to be 4.1. See, it took a little bit of time, but on your calculator, it should be about like 30, 40 seconds, I would say. It's only two parts, so that's what I recommend. It's an easy problem, you know. Now this problem, it's another geometry one. Some of y'all, I'm sure, might get a little bit, startled by this because you have no clue how to start. So hopefully this will help show you what to look for these problems. So we're asked for the hatched area, and we're given the side length of the square, and we're given that's the midpoint. So using that knowledge, we know that 95.8 divided by 2. This right here, this distance is 47.9. And that's important. We also can find the angle, because we know that's 90 degrees. We can find this angle. That's going to be important again later. So, and also, one thing with a square, I'm sure some of y'all have already noticed, this is a 45-degree right triangle right here. All of these angles are 45 degrees. Well, not all. That isn't, because that's not a diagonal. But that right there is 45 degrees. So is that. So is that. And where's the last one? Right here, 45 degrees. Okay, but the main important ones that I want you to know really is this one right here. That's 45 degrees. That's going to be important. So what I'm going to do, I'm just going to explain my reasoning, right? We know that this right here is half the whole square area, right? This huge part, this huge segment. I'm just going to draw over all this. That right there is half. So we're going to take half the area, zero point 0.8 squared, divided by 2. So this is the area of all this right here, right? That's that whole area. We have to subtract this little section right here. And I'm going to do that by using the triangle program, right? We know what this side length is, and we're finding out what this angle is, and we know what that angle is because if you look at this big triangle, it's a 45-degree right triangle, right? So using that to our advantage, we know that that's 45 degrees. We know what the side length is. We just have to figure out this angle, which we could use by, actually you could use SOHCAHTOA. This is the angle. It's 90-degree right triangle. That's the opposite. That's the adjacent. So just type in as you see it, and you're going to do the inverse tan of O over A, 95.8 divided by 47.9. And you get, did I mess up? O over A. Oh no, I didn't mess up, but I'm just in radians. That's why it's so small. Okay. Yep. There you go. 63.435 or so. So now you know what all the angles are. I'd write that down over here. 0.4. And it doesn't have to be really nice handwriting, hopefully better than mine, but as long as you could read it, it's not like you're having to show work for these tests, you know? I just do it because I want to understand my thought process and that y'all could see it too. Uh, okay, but now that we have two angles and we have the side length, we just use the triangle program. Angle, side angle, 45 degrees, right here. Then the side length, 47.9, and 63.435. Okay. Now we know what the area is, so that's saved under G. And then we just take, I think it's up here. Yep. Remember, this is the area of this whole section right here. Like I said, pretty bad with the mouse, but yeah, that's that whole section. And we're going to subtract the area of this little section, which is right there. And you get your answer to be 3,820. Okay, so that's, let me write that down actually. Oh, sorry. 3,820. Okay. Okay. Well, last page. What are we looking at? 53 minutes. Hopefully, we'll be done in an hour. Well, not within an hour. Just by the time the timer hits an hour. I meant. Okay. So this right here, ball dropped 5 feet below recovers 0.78 of its height. Now, for y'all that are in pre-cal, I know that some of y'all are, that is an exponential function. There's a ratio. That's the common ratio right there, and we're given the initial value. So it's quite simply, it's 5 times the ratio to the power of x. And we're asked when it will drop below 8 inches. Well, the initial value is in feet, so we're going to convert 8 inches to feet. So it's just going to be, oh no, my bad. We won't even need to graph it. That's going to actually even be worse. So we're asked for when the y falls under 8 inches, right? Since that right there is the output. So we're doing y1, we should set y1 equal to 8 divided by 12. And there you are. That'll give us, actually, let me check. I think you have to do y1 of x. That might have been my mistake. Or maybe, maybe that's not the first. I don't think that's right. I got it right the first time. I might have not wanted to do that exponential function though. There's another way you could do it though, which is it's just 5 again times 0.78 to the power of x. When does it fall just under 8 inches? Okay, well, I don't exactly know what I did wrong there because I thought I plugged it in right, but maybe I didn't. I got it right the first time around, but this time I just used the numeric solver. I plugged it in as I saw it in the numeric solver without the y equals and got the right answer. So it is 8.1, right? That's how many falls it takes. But it's an integer problem, right? And we're asked how many will occur, how many bounces will occur before it falls under 8 inches. Well, it has to be 9. We have to round up in this scenario. So we're going to use edit. Let me first crop it and markup, and that's going to be 9. You can't have 8.1 of them bounce, and if you say 8 bounces, well, that's not right because it will be above 8 inches. So you have to go to 9. I guess equals, I don't know if that's the best way to put it. I think I might want to do like that. That's not what I use. I don't know if it's correct, mathematically speaking, but I normally use that sign to show that you round it to 9. Okay, well, moving on. Exponent problem, very friendly. Once it loads, exponent 1.52 times 10 to the 21st is the negative 21st is the base, and then it's the power of 5,895. And gives you the answer. Multiply by, that's a different thing I added. Sometimes, last year especially, we had a problem that needed it, so I added it, but you don't have to worry about it for this problem. That's just your answer. 9.29 times 10 to the negative, that's a whole bunch of numbers, 2274. Terrible. Like I said, very bad handwriting, but as long as you can see it on the calculator, you know what I'm writing in, so that's good enough. Okay, this is a trajectory problem. 63 is always a trajectory problem. Some of y'all might know how to use the program, some of y'all might not. So this will be learning for all of y'all. So we're given the vertical distance. Well, first let me read the whole problem until I can explain it to you. So we're given a jumper that falls off a bungee jumper that falls off the Royal George Bridge, or Gorg? It's not George. Bridge, the tallest bridge in the United States. So she free falls half of it before it initiates deceleration. And what was the jumper's velocity at that moment? So we're asked about the moment halfway from this distance. So it's not the total distance, it's halfway. And how the trajectory program works, it will give you the velocity of a point at the beginning, not at the end. It doesn't give you the velocity when it hits the ground. It gives you the velocity when it gets off the ground, right? Or like when it starts its trajectory. So knowing that, we're actually, instead of going down, right, we're going to tell the program that we're actually going up, which will give us the right answer. So we're going to say that we're given the max height and distance. Maximum height is 955 divided by 2. And we're basically treating that halfway point as the ground, right? And then we're going to say the horizontal distance is negligible. You can't put 0, else it's going to get mad at you and give you an error. So just put it as 0.001. That's what I normally do. And then the initial height is 0. It's on the ground. It'll give us the velocity in feet per second, but we're asked in miles per hour. So again, the program doesn't say what variable it's stored under, so you could memorize it, or if you could guess, like I did eventually. V is velocity, and we're going to convert it to miles per hour. So we're going to divide it by 5,280 to put it in miles per second, and then we're going to multiply by 3,600 to put in miles per hour. And there you are, 120. If I believe that's the right answer. Yep. Okay, 2 more geometry problems and we're done. So almost there. Now, it will not be an hour, but maybe after I crop a couple things, like my little break, it will be. We'll see. Okay, so we're given 2 I shouldn't have really cropped this again, but it doesn't matter. Okay, so we're given, these are equilateral triangles. So that's 60 degrees. That's 60 degrees. I'm marking all the important angles that we'll need to use to our advantage. 60 degrees, so on and so forth. So there's several ways you could solve for this, but how I would do it is by taking the whole area of this thing, which we'll figure out in a second, and then multiplying it by the ratio that these equilateral triangles take up. And you'll see what I mean in a second. So since it's equilateral, that length right there is the same as that length up there. That's the same. So bang, bang, bang. That's important. So we know that these are all equilateral triangles. So these three angles have to all be 60. So that's 60. And by the way, you might immediately want to say this is a 90-degree right triangle, right? And you might want to say that that's a 90-degree right triangle, but they're not. And it tells us right over here, it's not a 30, 60, 90. If you said it's a 30, 60, 90, you'll be a little bit off. So we know that this angle right here, looking at this big triangle again, right, as I was saying before, looking at this big triangle, we're given two of the angles and a side length, right? So this angle right here is 29.5. This angle right here is 60. So if you do 180, right, the total area, the total angle of all the angles of a triangle, and you subtract both of them, you'll get really close to 90. You'll get 90.5, if I'm not mistaken. Yep, 90.5. So it's not quite a 90-degree right triangle. It's very close, but that if you assume it was, like I said, you'd be just enough off to not to get the question right. So knowing that, we can figure out the area of the triangle, of the big triangle again. So angle side angle, it's 3. Angle 1, 90.5, and then 34.5, and then 60. And I think it should give us the right answer without throwing us 2. Yep, 1046. That's the total area of this whole shape. Now, we're going to multiply it by the proportion that this equilateral triangle takes up. And I'm going to do that by figuring out the area of this whole segment right here, and then how much of this whole segment is made up by this equilateral triangle. So we're going to start off, in case you didn't know, the area of an equilateral triangle is super easy to find. It's just the side length of the equilateral triangle squared times the square root of 3 over 4. So that is the area of this triangle right here, right? And then you could look at this triangle, right? And we know side length. We know what this angle must be, since that angle right there is 60. It would be 30.5. This angle right here has to be 30.5. So again, we have side angle side, or sorry, angle side angle. So you can run the program again. Triangle angle side angle 3, 30.5. What is that? 34.5 again. Yep. And then finally 60. And you'll get the angle, you'll get the area again. So then you'll quit. It's saved under G. You'll go up. So this was the area of the equilateral triangle. This right there is the area of the smaller triangle. Add them together. That right there is the area of this whole section, 776. And if you divide the area taken up by the equilateral triangle by that angle, by that area right there, you'll get the proportion that the equilateral triangle takes up of the entire one, right? Because you'll see this pair every single time. Oh, like that was a terrible one, but you'll see a pair every single time. So if you figure out the ratio, which we did, you'll be able to find your answer this way. And you multiply by the total area, which is it up here? I don't remember typing it in. It's not. But if you multiply by the total area, 1046.6, you'll get your answer, 694, which is correct. Okay, we're on our last problem now. Not too bad, not too bad. I hope you all are keeping up. So now this problem is pretty friendly. But I want to have y'all think of it in a different way. So we know that this distance right here must be r, right? Same as that different distance. Well, I want to show y'all something pretty cool, right? In this scenario, if we were to double the rectangle, it would go down here and touch. If we were basically making it a circle, right? Well, I know it doesn't look like it, but if it's a total circle, those diagonals should be the same as well. And this whole thing would make a square, right? So that's very important later on. So we know that that's a square. So we could say that this right there, that side length is s over 2, and this whole thing is s, right? And we're asked for the angle right there. And we know that the hypotenuse is 0.155. So, and then that's 90 degrees, of course. What else? What else? So, knowing that, really friendly way to solve for it is 0.155, the hypotenuse squared, is equal to x squared, this whole base squared, plus 0.5x squared, which is this right there. So, using that, we'll get our side length. No, that does not look right. Let me check. So, yep, 2.258 squared. Oh, no, I see what I did. I did the square, but I also did the square root. It's one or the other. You're not supposed to do both. That was my mistake. Okay, that looks better. That's why whenever you're solving these problems, always just check to see if that answer looks reliable, if it looks accurate. If not, you did something wrong like I did there. But it only takes a second to figure out what you did wrong. So this right there is the side length, right? Now that we know that, we can figure out, we can do the hypotenuse and the adjacent side. So that's cosine. So the inverse cosine of a over h would give us the angle. Oh, I did one too many fives there. And it's 26.6, which is correct. So we worked through every single problem on this test except for 57? Yep. Well, I hope that helped. I'm probably going to make a couple videos for the other two tests we got this week. So I'm glad if you watched the whole video. It's not really benefiting me much, but it's benefiting y'all. So it's benefiting the team, and that's what's important. So I hope y'all learned something. If I did something wrong or you found a faster way to solve a problem, please let me know, because I'm not the best. I make mistakes. I've made several mistakes on this going through this thing, but we got there at the end. So it was good doing this. So I'll probably get it posted soon. All right. Well, y'all have a good day, and I guess check the classroom for when another video is going to release. I don't really know what else to say. So see y'all soon.